They found James Whittaker on the morning of November 14, 1828, collapsed on the dirt floor of his cabin near what would become Independence, Missouri. His wife Sarah stood in the doorway, her eyes streaming, lungs racked with coughing. Their 3 children huddled outside in the frigid air, preferring the biting wind to the suffocating interior of their home. The cabin had killed him, not with fire or collapse, but with something far more insidious. Week after week, month after month, James Whittaker had breathed smoke. Every time he tried to warm his family, gray clouds rolled back into the single room, settling like fog. The family slept with wet cloths over their faces. They woke gasping. Their eyes burned constantly. And on that November morning, James Whittaker's lungs finally surrendered. Sarah buried her husband 3 days later. By December, she had abandoned the cabin and moved back east with relatives. The structure stood empty, a monument to frontier failure, its blackened interior walls testament to the smoke that had claimed a life. The Whittakers were not alone. Across the expanding American frontier, from the Missouri borderlands to the Rocky Mountain valleys, settlers were dying in their own homes. Not quickly, like James Whittaker, but slowly. Chronic respiratory illness plagued frontier communities. Children grew up with persistent coughs. Adults aged decades and years. And the cause was everywhere, in every cabin, every winter day, when fires burned for warmth and cooking. Smoke. Relentless, toxic smoke that refused to leave through chimneys built by men who knew trees but not airflow, who understood axes but not thermodynamics. The problem seemed unsolvable. You needed fire to survive winter. Fire created smoke. Chimneys were supposed to remove smoke. But on the frontier, chimneys failed with devastating consistency. Settlers from the east brought building techniques designed for different climates and different wood. German and Swiss immigrants applied methods from their homelands that worked poorly in American forests. Everyone was guessing, improvising, and suffering the consequences of their errors. By the late 1820s, doctors in St. Louis were documenting what they called chimney lung, or cabin throat. Patients presented with chronic coughing, black phlegm, difficulty breathing. The condition was incurable because the cure required leaving your home. For frontier families with nowhere else to go, that was impossible. They lived in their smoky cabins or they died in them. But there was knowledge in the world that could have saved these families. Knowledge that existed in the minds of educated men back east, in the libraries of universities, in the writings of scientists. Knowledge that, for reasons of geography and class and timing, had not yet reached the rough log cabins scattered across the frontier. The answer to the frontier's smoke problem had been discovered decades earlier, thousands of miles away, by an American who had become a European aristocrat. And it would take a mountain man named Daniel Blackburn to bring that knowledge west. Daniel Blackburn was not a scientist. Born in Kentucky in 1796, he had moved west in 1822 to trap beaver in the Rocky Mountains. By 1828, he was a seasoned veteran of the mountain trade, known for his skill with traps and his uncanny ability to survive winters that killed lesser men. Blackburn spent summers trapping, attended the annual rendezvous to sell his furs, and wintered in cabins he built himself in sheltered valleys. What made Blackburn different was his past. Before heading west, he had worked for 3 years as a laborer on estates in Massachusetts, including a brief stint doing masonry work on a manor house in Boston. There, an old Scottish stonemason named Angus Mackenzie had taught him to build chimneys. Not frontier chimneys slapped together with mud and prayer, but proper chimneys designed using principles that Mackenzie had learned from builders in Edinburgh. Mackenzie had given Blackburn a small book. It was a printed pamphlet from 1798 titled Observations on Chimney Fireplaces with Proposals for Improving Them to Save Fuel by someone called Count Rumford. Blackburn had kept it, though he could barely read it. The language was dense, the drawings technical. But the old Scot had walked him through the concepts, showing him how to build what he called a proper throat and a smoke shelf. Blackburn didn't fully understand why it worked. Mackenzie had tried to explain something about air circulation and pressure, but those concepts meant nothing to a young man whose education had ended at age 10. What Blackburn understood was the practice. He knew how to angle the sides of a firebox. He knew how to create a rounded throat. He knew how to position a shelf of brick or stone at a specific height and angle. And he knew that chimneys built this way didn't smoke. For 6 years, Blackburn had built his own cabins with these features. His winter shelters were warm, smoke-free havens, while other trappers huddled in hazy, miserable structures. Other mountain men noticed. They asked questions. But Blackburn kept the knowledge to himself, partly because it gave him an advantage, partly because he didn't know how to explain what he only half understood. That changed in March of 1829. Blackburn had wintered in a valley near what's now Jackson, Wyoming. As spring thaw began, he planned to head to the summer rendezvous at Pierre's Hole. But fate intervened in the form of a Missouri settler family stranded in the mountains. Thomas and Rebecca Carter, along with their 4 children, had been part of a wagon train heading to Oregon Territory the previous fall. They had fallen behind due to a broken axle, and winter had trapped them in the mountains. Desperate, they had built a crude cabin using advice from another settler who clearly knew nothing about chimney construction. When Blackburn found them in late March, Rebecca Carter was dying. Her breathing was labored, her lips tinged blue. The children coughed constantly. Thomas looked years older than he probably was, his face gray, his eyes hollow. The cabin was filled with smoke so thick Blackburn could barely see across the single room. The family had been breathing smoke for 5 months. They were slowly suffocating. Blackburn could have moved on. The Carters were not his problem, but something about the children stopped him. Maybe it was the youngest, a girl of perhaps 4, who looked at him with streaming eyes and tried to smile. Maybe it was the knowledge that he could help. Maybe it was just decent human compassion. He stayed. First, he moved the family outside. They protested, claiming the cold would kill them. Blackburn pointed out that the smoke was already killing them, just more slowly. He erected a lean-to shelter using spare canvas and pine boughs, built an outdoor fire for cooking and warmth, and told the Carters they would live outside until he fixed their cabin. Then he examined their chimney. It was a disaster. Thomas Carter had built it using advice from another settler, stacking stones with mud mortar, creating a tall shaft that should have drawn smoke upward. In theory, it was correct. In practice, it was killing his family. The problems were multiple. The firebox was too deep and narrow, pushing most of the heat up the chimney and radiating almost nothing into the room. The throat, the narrow section between the fireplace and the chimney proper, was poorly shaped. It had sharp angles that created turbulence, causing smoke to eddy and swirl instead of flowing smoothly upward. There was no smoke shelf, that critical feature that created the circulation pattern needed to pull smoke reliably out of the home. Worst of all, the chimney itself was built directly against the exterior wall, making it susceptible to downdrafts when wind hit the cabin. Cold air rushing down the chimney pushed smoke back into the room, a phenomenon that had plagued the Carters every windy day. Blackburn spent 3 days tearing down the chimney to the firebox level. He salvaged the good stones, setting aside the cracked ones. He mixed fresh mortar using clay from a nearby creek bank, adding a small amount of lime he carried for tanning hides. The lime made the mortar stronger and less prone to cracking. Then he began rebuilding. First, he reshaped the firebox. The original was 36 inches wide and 30 inches deep. Blackburn reduced the depth to 18 inches while keeping the width and increasing the height to 30 inches. This created a tall, shallow firebox that would radiate heat forward into the room instead of sending it straight up the chimney. Thomas Carter protested. Surely a shallow firebox would be inefficient, unable to hold a proper fire. Blackburn showed him the mathematics of it, using his fingers to trace angles in the dirt. A deep firebox directed heat upward and outward. A shallow firebox with angled sides reflected heat forward like a mirror. The back wall became a reflector, bouncing radiant heat into the living space. Next, Blackburn angled the side walls. Instead of building them straight up and back, he set them at approximately 45 degrees, splaying outward toward the room. This created what he called wings that captured heat and directed it forward. The angled sides also reduced the volume of space where smoke could pool before entering the chimney. The fireback, the rear wall of the firebox, received special attention. Blackburn set it nearly vertical, with just a slight 5-degree forward slope at the top. This straight back wall was critical. It eliminated the pockets and corners where smoke could eddy and linger. At the top of the firebox, Blackburn created the throat, the most critical element of the design. This was the narrow passage between the firebox and the chimney shaft. Most frontier chimneys had throats that were too wide, too rough, or badly shaped. Blackburn's throat was smooth and streamlined. He started by setting stones to create the sides of the throat, narrowing the opening to about 1/10 the area of the fireplace opening. For a fireplace 36 inches wide and 30 inches tall, that meant a throat opening of roughly 108 square inches, approximately 14 inches wide and 8 inches tall. But the shape mattered as much as the size. Blackburn carefully selected flat stones and fitted them together to create a smooth, rounded surface. The sides curved gently inward, creating what he thought of as a funnel shape. There were no sharp edges, no abrupt transitions. Air and smoke flowing through would encounter minimal resistance. Above the throat, Blackburn built the smoke shelf. This was the feature that made the entire system work, though he understood it only in practical terms, not theoretical ones. The smoke shelf was essentially a horizontal ledge positioned directly behind and slightly below the throat opening. Blackburn built it by setting the chimney wall back about 8 inches at the level of the throat, creating a flat shelf extending the full width of the chimney interior. Thomas Carter watched this work with confusion. "You're putting a shelf in the way of the smoke. Won't that block the flow?" Blackburn shook his head. "Watch the smoke when we light the first fire. The shelf doesn't block it. It guides it." What neither man fully understood was the physics at play. The smoke shelf created a critical discontinuity in the airflow path. When smoke rose from the fire and hit the rounded throat, it accelerated through the narrow opening. But instead of shooting straight up into a wide chimney shaft, it encountered the smoke shelf. This created a circulation pattern. Outside air, drawn down the chimney by wind or temperature differences, hit the smoke shelf and was deflected forward into the throat. There, it mixed with rising smoke, creating a rotating flow. The mixture of cold outside air and hot smoke had a higher combined volume and velocity than either component alone. This mixed flow rose up one side of the chimney, while outside air descended the other side. The smoke shelf essentially created a pump. It forced the incoming cold air to blend with outgoing smoke, producing a powerful updraft that pulled smoke out of the firebox continuously. Downdrafts, the bane of frontier chimneys, were neutralized because the descending cold air never reached the firebox. It hit the shelf mixed with smoke and immediately reversed direction to flow upward. Blackburn built the chimney shaft above the smoke shelf to be about 14 inches square in interior dimension, roughly 196 square inches of area. This was larger than the throat, but small enough to maintain good flow velocity. The walls were 2 stones thick for strength and insulation. He kept the chimney interior as smooth as possible, carefully pointing the mortar joints to create even surfaces. Every irregularity in a chimney created turbulence and reduced draft. Blackburn had learned this from Mackenzie, though he couldn't explain why. The height of the chimney was critical. Blackburn built it to extend at least 3 feet above the peak of the cabin's roof. Shorter chimneys suffered from wind issues. Wind blowing across the cabin roof could create pressure zones that pushed smoke back down short chimneys. A tall chimney shaft extended into cleaner airflow above the turbulence created by the cabin itself. The entire reconstruction took 8 days. Rebecca Carter's breathing began to improve as soon as they moved outside, away from the constant smoke exposure. By the time Blackburn finished the chimney, she was walking around the camp, still weak, but recovering. On the 9th morning, Blackburn lit the rebuilt fireplace for the first time. Thomas Carter, Rebecca, and their children gathered to watch, skeptical that the strange new design would work any better than the old one. Blackburn had warned them that new mortar needed to cure properly, and the first fire should be small. He arranged kindling in the shallow firebox, struck sparks from his flint and steel, and coaxed flame from the tinder. Smoke rose from the burning kindling, hit the rounded throat, and vanished up the chimney. No smoke entered the room, not a wisp. The air remained clear. Blackburn added larger pieces of wood. The fire grew. Heat radiated forward from the shallow firebox and the angled side walls, warming the space in front of the fireplace. Still, no smoke leaked into the cabin. Thomas Carter's eyes widened. "I've never seen a chimney draw like that." Blackburn nodded. "That's how they're supposed to work." He showed Thomas how to manage the fire. Keep it moderate. Don't overfill the shallow firebox. Use dry wood when possible. Add logs to the rear, where the straight back wall allowed them to catch flame efficiently. That evening, the Carter family slept inside their cabin for the first time in 3 weeks. They woke the next morning to warmth and clear air. Rebecca wept with relief. Blackburn stayed another week, showing Thomas other improvements. He helped them chink the gaps between logs properly, using a mixture of wood chips, clay from the creek bank, and dried grass packed tightly into the spaces. They mixed the chinking mortar using 2 parts clay, 1 part sand, and water, until it reached a workable consistency. On top of the chinking, they applied a daubing layer of finer clay mixed with a small amount of animal hair from their horses, which added strength and prevented cracking. The cabin's original chinking had been inadequate. Thomas had simply shoved moss and mud into the gaps without proper technique. Those gaps let cold air stream through the walls, creating drafts that made the heating problem worse. Proper chinking sealed the cabin, allowing the improved fireplace to heat the space efficiently. Blackburn also showed them how to position the fire for maximum heat. He explained that placing logs at the back of the shallow firebox, leaning slightly forward, created the best combination of flame visibility and heat radiation. The fire should be compact and hot rather than spread out and smoldering. Before leaving, Blackburn drew simple diagrams in a blank section of Thomas Carter's Bible, the only paper the family owned. He sketched the dimensions of the firebox, the angle of the sides, the shape of the throat, and the position of the smoke shelf. He made Thomas copy the drawings to be sure the man understood them. "If you meet other settlers struggling with smoke," Blackburn said, "show them this. Tell them how it works." Thomas Carter shook his hand. "I'll tell everyone I meet. You saved my family's life." Blackburn shrugged, uncomfortable with gratitude. Just a proper chimney, nothing fancy about it. But it was fancy in its way. It represented knowledge developed over centuries, refined by European scientists and craftsmen, formalized by a Massachusetts-born count working in Bavaria and London. And now, through an accident of fate, that knowledge was spreading westward. The 1829 summer rendezvous at Pierre's Hole brought together hundreds of mountain men, traders, and Native Americans. The gathering was part market, part festival, a chance to sell furs, buy supplies, share stories, and drink prodigious quantities of whiskey. Daniel Blackburn arrived in late July with his winter's worth of beaver pelts. Word of his encounter with the Carter family had spread. Mountain men heard stories of a trapper who could build chimneys that never smoked, who had literally saved a dying woman by rebuilding her cabin's fireplace. Men approached Blackburn constantly, asking about the technique. He found himself surrounded by trappers wanting to know the secret to smoke-free cabins. At first, Blackburn was reluctant to share. He had held this knowledge as a private advantage for years. But the attention was overwhelming, and something about the Carter family's near death had changed his perspective. This wasn't knowledge meant to be hoarded. It was too important. He began teaching. Using a flat rock as a drawing surface and charcoal from the campfire, Blackburn sketched the design principles. He showed the shallow firebox, the angled sides, the rounded throat, and the smoke shelf. Men crowded around, studying the drawings, asking questions. How shallow should the firebox be? 1/3 as deep as it is wide. A 3-foot wide fireplace should be 1 foot deep. How narrow should the throat be? About 1/10 the area of the fireplace opening. You measure the height times the width of your fireplace opening, then divide by 10. What exactly does the smoke shelf do? Blackburn struggled to explain that. He described how cold air coming down the chimney hits the shelf and gets pushed back up, mixing with smoke. Several men looked skeptical. It didn't make intuitive sense. A shelf in the middle of a chimney should block smoke, not help it escape. I know it sounds backwards, Blackburn admitted. But I've built 6 chimneys with smoke shelves, and none of them smoke. I've seen chimneys without them, and they all smoke sometimes. The shelf works. I don't know why, but it works. A trapper named Robert Meeks, who had spent winters coughing in smoky cabins, pressed for details. You really think this matters? I mean, we've all dealt with smoke. It's just part of cabin life. It doesn't have to be, Blackburn said. The settler family I helped, the wife was dying from breathing smoke. Their kids had coughs that wouldn't stop. After I fixed the chimney, the air cleared. Within days, the woman could breathe again. This isn't just comfort, it's survival. That resonated. Every mountain man at the rendezvous had experienced the misery of a smoky cabin. Winter quarters were supposed to be refuge from the brutal cold. Instead, they were often as dangerous as the wilderness itself. Over the next 3 days, Blackburn gave informal instruction to dozens of men. He drew diagrams repeatedly. He explained the dimensions, the angles, the features that mattered. He described the construction process, the materials that worked best, the common mistakes to avoid. He also discovered that he wasn't the only person who knew about this design. A French-Canadian trader named Baptiste Moreau mentioned that some of the old stone houses in Quebec had similar fireplaces, built by masons who had brought the knowledge from France. An educated trapper from Virginia named William Preston said he had read about something called Rumford fireplaces in a book back east, though he'd never seen one actually built. The knowledge existed. It just hadn't reached the frontier in a practical, usable form. Blackburn was translating educated concepts into rough-hewn practice, turning book learning into something a man with an axe and a pile of stones could actually build. Word spread beyond the rendezvous. Mountain men who learned the technique from Blackburn built improved chimneys in their winter cabins. Some of them taught others. The knowledge began to propagate through the frontier like ripples from a stone thrown in a still pond. By 1831, improved chimney designs were appearing in settlements across Missouri and into Kansas Territory. The technique wasn't standardized. Different builders made different modifications based on available materials and personal interpretation. But the core principles remained. Shallow firebox, angled sides, smooth, rounded throat, smoke shelf, tall chimney shaft. These features became markers of competent construction. The transformation wasn't instantaneous or complete. Many settlers continued building chimneys the old way, either because they hadn't heard about the improved design or because they didn't believe it would make a difference. Plenty of people built hybrid versions that incorporated some features but not others, usually with mixed results. But gradually, the frontier's housing improved. Doctors in towns like St. Louis and Independence began seeing fewer cases of severe respiratory illness in newly arrived families. The connection wasn't obvious. Most people didn't realize that improved chimneys were responsible, but the statistical improvement was real. The smoke shelf, that seemingly simple feature, made the critical difference. Without it, chimneys could work, but they were unreliable. Wind, weather, fire conditions, all of these variables could cause smoke to billow back into a room. With a properly constructed smoke shelf, chimneys became forgiving. They worked in almost all conditions. The physics of why it worked remained mysterious to the builders. They knew the practice, but not the theory. Air circulation patterns, pressure differentials, the mixing of flows at different temperatures. These concepts existed in scientific literature, but had not reached the frontier in practical form. What had reached the frontier was the method, and methods were enough. By 1835, Daniel Blackburn had retired from trapping. At 39, he was old by mountain man standards. His joints ached, his eyesight was failing, and he had accumulated enough money from fur sales to buy land. He settled near Independence, Missouri, where a growing town served as the jumping-off point for westward migration. There he found a new occupation. Settlers heading west needed cabins. They needed chimneys that worked, and Blackburn knew how to build them. He took on apprentices, young men who wanted to learn masonry and carpentry. He taught them the chimney technique, showing them how to build fireplaces that would keep their families warm and smoke-free. His students spread across Missouri, Kansas, and eventually into territories farther west. Blackburn never wrote a book. He never published articles or gave formal lectures. His contribution to frontier life came through direct, practical teaching. But the impact was profound. Thousands of families lived in warmer, healthier homes because one mountain man had learned proper chimney construction from a Scottish stonemason in Massachusetts and had taken the time to share that knowledge. The technical specifications that made the design work were precise but not complicated. Any reasonably skilled builder could implement them with basic tools and local materials. For a typical frontier cabin, 16 feet by 20 feet, the fireplace would be positioned on one of the shorter walls, usually at the end of the cabin. The firebox opening would be approximately 36 inches wide and 32 inches tall, creating 152 square inches of opening area. The depth of the firebox would be 12 inches, creating a 3.1 ratio of width to depth. This shallow profile was critical. Deeper fireboxes, common in traditional designs, projected heat upward and outward, wasting most of the thermal energy. The shallow profile concentrated heat radiation into the room. The side walls of the firebox would angle at 45 degrees, creating a splayed opening that reflected heat forward. These angled surfaces effectively doubled the radiant heating area because the sides themselves became heat reflectors rather than just structural walls. The back wall would be nearly vertical, perhaps sloping forward by 5 degrees at the top. This straightness eliminated corners where smoke could pool. The back wall also served as a primary reflector, bouncing radiant heat toward the center of the room. At the top of the firebox, 32 inches above the hearth, the throat began. This transition from firebox to chimney shaft was the most critical element. Blackburn taught his students to create throats with approximately 115 square inches of area, roughly 1/10 of the fireplace opening. The throat shape mattered more than its precise dimensions. It needed to be smooth and rounded, without sharp corners or abrupt transitions. Builders achieved this by carefully selecting and positioning stones, sometimes using mud mortar to fill gaps and create smooth curves. The goal was to create a streamlined path that accelerated smoke flow without creating turbulence. Immediately above the throat, at the transition point where the throat opened into the chimney shaft, the smoke shelf was built. This required setting the back wall of the chimney about 8 inches farther back than the back wall of the throat, creating a horizontal shelf. The shelf was not decorative or structural. It was functional, creating the discontinuity in airflow that produced the circulation pattern required for reliable smoke removal. Outside air descending, the chimney struck the shelf and was forced to reverse direction, mixing with rising smoke to create a powerful combined updraft. Above the smoke shelf, the chimney shaft extended upward. The interior dimensions were typically 14 inches by 14 inches, creating 196 square inches of area. This was larger than the throat, but maintained high enough flow velocity to ensure strong draft. The walls of the chimney shaft were built from stones mortared together, 2 stones thick for insulation and strength. Interior surfaces were kept as smooth as possible. Rough interiors created turbulence that weakened draft and increased creosote buildup. The height of the chimney above the cabin roof was determined by practical testing. Blackburn taught that the chimney should extend at least 3 feet above the highest point of the roof, preferably more. Taller chimneys drafted better because they extended above the turbulent air created by wind flowing over the cabin. For mortar, Blackburn used whatever local materials worked. In most frontier locations, clay was available from creek banks or exposed soil. Good mortar consisted of approximately 2 parts clay, 1 part sand, and enough water to create workable consistency. Adding a small amount of lime, if available, improved durability and water resistance. The hearth, the floor of the fireplace, was built from flat stones laid directly on packed earth or on a base of stones and mortar. The hearth needed to extend at least 16 inches in front of the fireplace opening to catch sparks and hot coals. Side extensions of 8 inches provided additional protection. Building one of these improved fireplaces took a skilled mason about 4 to 6 days of work, assuming materials were available and weather cooperated. The time investment was worth it. A well-built chimney would last decades with minimal maintenance, providing reliable, smoke-free heating throughout that entire lifespan. The technique spread beyond individual builders. By the 1840s, carpentry manuals published in the East began including sections on improved fireplace design. The books didn't credit Blackburn or any individual innovator. They presented the designs as established practice, which in many ways they had become. But the knowledge hadn't started as established practice. It had entered the frontier through specific individuals who took the time to learn and teach. Blackburn was one of those individuals. So was Angus Mackenzie, the Scottish stonemason who had taught him. And behind them both was Count Rumford, whose scientific investigations of heat and combustion had produced the original design principles. This chain of knowledge transfer from scientist to craftsman to frontiersman to settler represented how practical information moved through society in the 19th century. It was slow, often incomplete, sometimes garbled in transmission, but it was effective. By 1850, the improved chimney design was standard practice across much of the frontier. The difference it made in people's lives is hard to quantify, but easy to imagine. Families who would have spent winters coughing and miserable instead lived in relative comfort. Children who might have developed chronic respiratory problems grew up healthy. Settlers who might have abandoned their cabins and returned east instead persevered and thrived. The improved chimney didn't solve all frontier challenges. Life remained hard, dangerous, and often short. But it removed one significant hazard, making survival measurably more likely. Daniel Blackburn died in 1867 at age 71, an impressive lifespan for a man who had spent years in the mountains. He was buried in a cemetery outside Independence, his grave marked with a simple stone that identified him as a stonemason. There was no mention of his role in spreading improved chimney design across the frontier, but his legacy lived in thousands of cabins. Every time a family gathered around a warm, smoke-free fireplace on a winter evening, they benefited from knowledge Blackburn had helped transmit westward. They might not have known his name or understood the history of the techniques their chimney embodied, but they experienced the results. The story of frontier cabin heating is ultimately a story about knowledge transfer. Complex technical information, developed through scientific investigation in Europe, had to travel across oceans and cultures and educational divides to reach people who needed it. That journey required intermediaries, masons who could read scientific papers and translate them into practice, laborers who learned by observation and carried knowledge westward, mountain men who recognized the value of superior techniques and chose to share rather than hoard. Without those chains of transmission, thousands of frontier families would have suffered needlessly. The knowledge existed, but knowledge in isolation helps no one. It must move, adapt, and find the people who need it. The smoke shelf, that simple architectural feature, represents a broader truth about human progress. We advance not through individual genius alone, but through the accumulation and transmission of understanding across generations and geographies. Someone figures something out. Someone else learns it. The knowledge spreads. Lives improve. On the American frontier, that process was visible in the transition from smoky, dangerous cabins to warm, comfortable homes. The difference was just a few design features in a stone chimney. But those features transformed daily existence for everyone who encountered them. Today, modern heating systems have made the details of fireplace design less critical. We control climate with thermostats, burn clean fuel, and rarely think about smoke or draft or the physics of combustion. But the principles discovered by Count Rumford and spread by men like Blackburn remain valid. They work in any era with any technology level because they're based on fundamental physical relationships that don't change. The improved chimney design represents a kind of knowledge that frontier communities desperately needed. Practical, implementable, immediately beneficial. It wasn't theoretical. It didn't require specialized tools or rare materials. Any capable builder with stone, mortar, and understanding of the key principles could construct a chimney that worked reliably. That accessibility made the difference. If the improved design had required advanced tools or exotic materials, it would have remained inaccessible to frontier builders. But because it could be implemented with resources available in nearly any location, it spread rapidly once the knowledge was introduced. The mountain men who learned proper chimney construction from Blackburn didn't become famous. Most of them left no written records. They lived, trapped, built cabins, taught others, and died without anyone recording their contributions. But collectively, they transformed frontier housing. Every winter, across thousands of cabins in Missouri, Kansas, Colorado, Wyoming, and Montana, families stayed warm without smoke because someone had learned proper chimney design and passed that knowledge forward. The children who grew up in those cabins, breathing clean air, had better health outcomes than they would have otherwise. Some of them became builders themselves, continuing to spread improved techniques. By the 1860s and 1870s, as railroads penetrated westward and factory-made cast iron stoves became affordable, the era of stone fireplace chimneys began to wane. Stoves were more efficient, easier to install, and didn't require skilled masonry work. But the improved fireplace design remained relevant in regions where stone was plentiful and stoves expensive. And the broader lesson, the importance of sharing practical knowledge, remained eternally relevant. Technical information doesn't disseminate automatically. It requires people willing to teach, to learn, to pass knowledge forward. Without those human connections, superior techniques remain trapped in books and expert minds, unavailable to the people who need them most. Daniel Blackburn, mountain man turned stonemason, made that human connection. He learned from Angus Mackenzie. He taught settlers at rendezvous gatherings. He took on apprentices. He built hundreds of chimneys, each one a physical embodiment of knowledge transferred from European scientists to American frontiersmen. The families who lived in cabins with Blackburn-designed chimneys probably never knew the chain of knowledge that made their comfort possible. They didn't know about Count Rumford's investigations in Bavaria or Angus Mackenzie's masonry work in Edinburgh. They just knew their chimneys worked, their homes were warm, and their children could breathe clean air.